Today's video is covering 2.5 and 2.6, addition equations and subtraction equations. Before I even write anything, I want to say that the biggest challenge in this particular lesson is convincing you that you shouldn't just do the question mentally, okay? The goal here, again, isn't so much the answer. It's learning to do a process so that when you're solving much more difficult equations, or when you're solving equations that you couldn't just look at it and do mentally, that you have something you can do to solve them. And you can learn from past students' errors. There are kids that have ignored me, and they just do these mentally and don't really try to fit the inverse operation process into what they're thinking. And then as soon as we try to do it with fractions or anything harder, then it falls apart and they don't know how to do it. So kind of follow through with the process so that you have a method when things become harder, okay? Or more difficult. All right, so I said inverse operation. So inverse kind of means opposite or reverse. So an inverse operation does the opposite thing of its counterpart. So the inverse operation to addition is subtraction. The inverse operation to subtraction is addition. The inverse operation to multiplication is division. And the inverse operation to division is multiplication. Kind of makes sense. So if I start with an addition equation, it might be something like x plus 5 equals 15. Yeah, x is 10. I know, you know. But this is our first example, and we're just starting to practice to solve these so that we can do more difficult ones. So this is addition. What is the inverse operation to addition? Subtraction. So I'm going to subtract 5 from this side of the equation, and I'm going to subtract 5 from this side of the equation. If you have a sibling at home, if this is you and this is your brother, if your parents do something or have you do something that they don't have your brother do, or if they give you money and your brother doesn't get money, it's got to be fair, right? So the same kind of thing is true with an equation, except in the equation it keeps it balanced and gives you the correct answer. So this is fair if I treat both sides of the equation equally and subtract 5 from both sides. Not only is it fair, it'll be right. Now if I have positive 5 and minus 5, this ends up being nothing. If I have 5 minus 5, I have nothing. So what's that leave me with? Just x, which is kind of my goal, to isolate my variable. And that will be equal to 10. Okay? The second half of your directions will tell you to check it. So you take your original and you put in the value you got. So 10 plus 5 equals 15. Is that true? You can say it checks. So for me, this is all you have to do a check. Okay, one little line. If it were a more difficult equation, it might take more than one line to check it, but in this case, this is all you need to do. Okay, equation, single step to isolate, solution, check the solution. Okay, I'll do one of those again quickly. X plus 17 equals 32. Okay, just a slightly bigger number. Maybe still can do it in your head. I'm going to do the inverse operation of addition, which is subtraction. I'm going to subtract 17 from both sides. So now x is equal to 15. If I need to do a little computation to figure out that 32 minus 17 is 15, I could do that. Let's check it. 15 plus 17 equals 32. Does it? Yep. Check. Okay. The only other thing that sometimes freaks people out a little bit on these is they can move stuff around on you and it'll still work. If I have 12 plus m equals 15, okay, this is still a positive 12, right? This is still a plus 12 situation, so I want to subtract 12 because that will now be 0. And I'm going to subtract 12 over here. So now m equals 3. Didn't matter that the letter came after the number. Check it. 12 plus 3 equals 15. I put 3 in for m because I got that m was 3. Does that equal 15? Yep. Check. Okay. It'll even work if the constant, the plain old number, is over here. If this says 72 equals 50 plus m, okay, well, here's where the variable is. I want this out of here. My goal is always to get this variable by itself. Isolate the variable will let me solve for it. So this is a plus 50, so I'll do minus 50. M equals 22. We should have lined that up a little bit better. 72 equals 50 plus 22. Sure does. Check. Okay, subtraction. works very similarly. The only thing is there's a different inverse operation. So if I have x minus 5 equals 12, what's the inverse operation of subtraction? Addition. So now I'm going to add 5 to both sides. This still equals 0. So I have x equals 17. Still check it the same way. 17 minus 5 equals 12. Does it? Yep, that's 12, that's 12. It checks. Okay. Maybe it's on the other side. Maybe 15 equals x minus 2. Where's my variable? Right there. I want to isolate my variable. So I need to get this minus 2 or subtract 2 out of here. I'll do the inverse of subtraction, which is addition. Add 2, x equals 17. Check it. 15 equals 17 minus 2. Yep. I don't know why so many 17s. It checks. I'm done. Okay? Again, I know you can figure them out mentally. I can figure them out mentally, but this is the first step to being able to do a question that maybe looks something like this. That's harder than this. You don't know what it meant actually. Yeah. It's a good question. Thank you.